So I think you had doubts in the third part of this thing. Third question. So let us look at that. All right, so in third question, we have to find expenditure functions for the different parts on part one in the second question, basically. So let us look at how to find the expenditure functions. So let us look at this first one, 3x plus lny. Okay. Switch off this application. Okay, 3x plus lny. So my utility is equals to 3x plus lny. Okay. I have to find the expenditure function. So the things to solve for in expenditure function are going to be a utility constraint and a utility constraint. Okay, that's going to be u of x comma y equals to some value u naught, and second is your MRS equals to price ratio. So these are going to be your two constraints when you solve for the expenditure function. So the solution. So in the solution, we first look at MRS equals to price ratio. So MRS is 3 del u by del x upon del u by del y. Right? So what's wrong with this? Del u by del x upon del u by del y. So del u by del x is 3, del u by del y is 1 by y. So this is equals to 3y. Right? So the utility function, the MRS function is 3y, and the utility constraint is 3x plus lny equals to u naught, which implies that y lny should be equals to u naught minus 3x. Okay, which implies that y should be equal to e to the power u naught minus 3x. Okay. Now this 3y should be equal to price ratio px upon py. So this implies that y must be equal to px by 3py. So this is equation number 1. This is equation number 2. You solve 1 and 2 simultaneously. So what you get is px upon 3py must be equal to e to the power u naught minus 3x. Okay. So this is going to be your expenditure function. Obviously, I want to derive everything in terms of x star Hicksian demand. So what I get is u naught minus 3x must be equal to log of px upon 3py. Okay, rearranging this thing. Okay, so finally your x star equals to u naught minus log of px upon 3py, which implies that y star will simply be equal to, you can use either of, so y star will be equal to this much, right? Y star is equals to px by 3py. Okay. Now, obviously, one condition here is that both x star comma y star must be strictly greater than equals to 0. Both x star and y star must be greater than equals to 0. So my question is to Himandi. What is the condition? Yeah, yes, Kritika.
Yeah, I was saying like x star is divided by 3, right? Because there is 3x.
X star, yeah, sorry, 1 by 3. 1 by 3 times, yes. Yeah, correct. Okay, yeah, Himandi. So my question to you is, what is the condition on u naught px and 3 and py such that x star is greater than equals to 0?
So u naught greater than ln
Hmm.
px by 3py.
Very good. Okay, that's it. Okay, that's it. That's a very simple answer. Okay, so for x star greater than equals to 0 means u naught must be greater than equals to this value. If u naught is less than this value, then what happens is that x star becomes negative. So dot is not allowed. So your this condition must be satisfied. So your final Hickson demand, okay, let me write this as xh and yh, because x star y star is used for Marshallian demand, right? So let me not confuse it. Let me write xhyh. So x Hicksian. So final thing is x Hicksian comma y Hicksian is equal to this value u naught minus log px by 3py comma px by 3py if, let me call this as condition A, if A is true. Okay, what happens if A is not true? What happens if A is not true, if this condition is the reverse? Okay, if u naught is less than this thing, so what happens in this case?
Xh will be equal to 0.
Very good, very good. So x becomes equals to 0. So come back to this equation. Okay, so in this equation, I'm taking x equal to 0. So what happens to value of y? So ln y must be equal to u naught, which implies y must be equal to e to the power u. So this thing becomes 0 comma e to the power u naught. Okay, so that is how you can find your Hickson demands. Now, once you find your Hickson demand, the expenditure function is still not found. The expenditure function is simply px p vector dot xhyh. Okay, so the expenditure function e dot is, it should be small e. E dot will be equal to px comma py dot xh comma yh. Okay, so we have this format. You just take a dot product with px py, that is pxxh plus pyych. That becomes your expenditure function. So that could also be a piecewise function, a true and a false type relation, I guess. So this takes care of question number 1. Okay, what other question do you want me to do here?
E.
E, okay, min of alpha x comma beta y. Utility equals to min of alpha x comma beta y. Okay, so this is very straightforward. If you want utility level u naught, then what you need is alpha x must be equal to u naught and beta y must also be equal to u naught, which implies x equals to u naught by alpha and y Hicksian equals to u naught by beta. So the final expenditure function is Px xh plus Py yh, which is going to be equal to Px times Px by alpha plus Py by beta times u. So this is your expenditure function. Okay. So in the MIM case, what's happening is, suppose these are my ICs, and suppose I want to reach this level of utility U naught, and assuming that I have some ICs which maybe look like this. Then as you can see, the cheapest way to reach this bundle is at the vertex. This is the first indifference curve. So as you move away from the origin, you are increasing expenditure. The aim is to minimize expenditure. The point with minimum expenditure is going to be this one. Okay, so this is going to be the vertex point. So it is at the vertex that the expenditure is minimized. So that's why the equation of the vertex is alpha x equals to beta y, and they should both be equal to u naught. So that is what we are solving. Alpha x equals to u naught is first equation, beta y equals to u naught is my second equation. Okay. All right. What else?
With J.
Okay. So J part, utility equals to negative of x minus 2 whole square plus y minus 2 whole square. Okay, so utility values are going to be definitely negative. Okay, nothing other than negative is possible. 0 and negative, so they cannot be positive. So utility has to be greater, less than or equals to 0. That is the case for this particular level of utility. Okay. Now, what are the ICs going to look like? So these are going to be concentric circles centered at 2, 2. So around 2, 2, I can draw concentric circles. Okay, so these are going to be my indifference curves. And uh, in which direction are they increasing? Are they increasing away from this center, or are they increasing towards the center? Which utility, which indifference curves are higher? Which indifference curves represent higher utility? Kashish, why don't you answer this one? Hello, Kashish. Yeah, I can hear you with some noise. It's not very clear, but I can hear you. So my question is, if you were a consumer, yeah, are utilities increasing towards this center or away from the center?
The away part.
Okay, that's wrong. Okay, because away from the center, it's going to be strictly negative. Your utility is 0 here. You go anything. So at 2, 2, utility at 2, 2 is 0. Utility at anything other than 2, 2 Any other point x comma y is strictly negative. So this is 0. This is the most preferred outcome. Everywhere other than 0 comma 0, you're going to have a negative utility. Okay. So you want to be at this point 2 comma 2. So now the question is, what happens to utilities? So if the aim, so the expenditure function, so I have to go back to the expenditure function thing. So the expenditure function tells me the minimum expenditure such that utility is greater than or equal to some pre-specified level of utility u naught. Okay, so if the pre-specified level of utility is, let's say, 0. Okay, so if I specify u naught equals to 0, so what is the minimum expenditure in which you can reach 0? Or rather, the question is, which bundle will you have to choose to reach utility 0? Come on, there's only one bundle here which can make you reach 0. What is that bundle?
2 comma 2.
Yes, 2 comma 2. So the expenditure to reach 0 is going to be 2px plus py. Okay. The other thing is, what is the utility at 0 comma 0? Let me ask this to you. Yeah, -4. Okay, -8. -8, yeah. There's -2 square plus -2 square, so negative of 4 plus 4, so that is -8. So you can reach a level of utility -8 without any expenditure, and you can reach the maximum possible utility with an expenditure of 2px plus py. Okay, so if my u naught is less than -8, suppose u naught is equal to -10. Suppose I have to reach a level of utility minimum -10. Right, so you have to go back to the definition now. So suppose this is the indifference curve corresponding to -8, and this is the indifference curve corresponding to -10. Now, without any expenditure, you can reach -8, which is higher than -10. So why would you even spend anything or do anything other than that? You're saying that without spending anything, I'm at -8, which is greater than -10. Okay, so for all u naught greater than equals to -8, the ideal bundle xh comma yh is going to be 0 comma 0. Because if without doing anything you are at -8, why would you want to spend something and reach specifically -10 comma -10? Okay, so this bundle, let me call this as bundle B, is at -10 utility. But I don't want to reach here because reaching here is costly. Without spending anything, I am at a higher utility. So why would I want to spend and reach a lower utility? Right? That doesn't make sense. Does everybody get this point? Yeah, I hope everybody gets this point. Okay, so for any utility lower than less than equal to -8, less than equals to -8. For any utility level lower than -8, the ideal bundle is going to be 0 comma 0. Now for a utility level, so this is the box in which I will have a utility level lower than between -8 and 0. Okay, so for all u naught belonging to -8 to 0, what is going to be the ideal bundle? So let's say you want to reach this particular indifference curve, this utility level, let's say this is -4 or -2, -2. So then the ideal bundle to do this would be the tangency curve. So then you solve. So for this case, you are going to solve for tangency and utility constraint. So tangency is going to be MRS equals to price ratio, and uh, yeah, MRS equals to price ratio, and the other thing is your utility constraint, that is U naught equals to U of X comma Y. Okay, so that will give you the cheapest bundle to reach this level of utility. So let us do that. Let us do that. So let's find the MRS equals to price ratio condition for this case. So your utility function is negative of X minus 2 whole square plus Y minus 2 whole square, which implies MRS will be equal to del u by del x upon del u by del y. So when you differentiate with respect to x, you get negative of twice of x minus 2 upon negative of twice of y minus 2. So this cancels out, so it becomes x minus 2 upon y minus 2. So that is your MRS. Okay, and this should be equal to your price ratio. So x minus 2 upon y minus 2 must be equal to px upon py. The other thing is going to be, so you can just replace x minus 2 with this thing. The other thing is negative of x minus 2 whole square plus y minus 2 whole square is equals to u1. So you can use these two equations and solve it. A good thing would be to make some substitutions. Let's say x minus 2 is capital X, this is y. So what you get is capital X by capital Y equals to px upon py, and negative of x square minus y square is equals to u1. Okay, or you can write this as x square plus y square, or x square plus y square equals to negative of u1. Okay, then you can make some substitution here that px x can be equal to px by py whole square plus 1 times of y square equals to u naught. So this gives you y equals to under root of u naught by 1 plus px by py whole square. And then you put this back here to get the x value. Okay, so this is how you can do it. So this is pretty analytical. So for different values of u naught, you will get different things. For u naught value lower than -8, the ideal expenditure is 0. For u naught value between -8 and 0, you will get this particular function. And u naught value greater than 0 cannot happen. Okay, sorry, this is going to be negative u naught, minus of 2. All right. Okay, any other doubt from this part?
Sir, how we have to construct the graph of indirect utility function? I missed that class. That's why I'm asking.
Graph for which particular function?
So that min of 3x plus y comma x plus 2y.
So why didn't
G
you
part.
attend the recordings? Have you attended the
Sir,
recordings?
yeah, sir, the recording started from the expenditure function only. I've
Okay.
seen that whole recording.
Okay, so why don't you go, let me tell you, because it's a long topic. I cannot take the entire topic. I'll be happy to take doubts, but first you'll have to watch the recordings. So you go into just let it open. Okay, so go into your batch, then go into videos. Then you need to go into consumer theory, microeconomics, consumer theory, and go into lecture videos. And it's, I don't know what happened to the arrangement of these videos. They used to
Sir,
be
I wasn't
in order.
able to find that. I looked it for that in this part, but I wasn't able to locate it.
Okay, let me see. It should be here somewhere. Marshalian demand curves. Okay, let me take another class for that, because now you see others are also attending and they would have attended this topic. So let me find if I can find a video for that. If not, I'll take a separate class for that. Okay.
Okay, sir.
Hmm. All right. So I'm guessing no more doubts from this part. So let us move to the next thing, the variant test banks. So I think we have discussed the first two chapters. I'm not sure. Where do we have to take up from?
I have doubt from preferences.
You have doubt from preferences. Okay. So I'll start from preferences.
Then multiple choice question 3.18.
Let me open this. Kashish. Yeah. Tell me question number.
So for multiple choice question 3.18.
Okay, Nancy Lerner is taking a course from Professor Goodhart, who will count only her best midterm grade, and Professor Stern, who will count only her worst midterm grade. So grade in Professor Goodhart's class is going to be max of different scores in midterms, max of all the marks in different midterms I, and grade in Professor Stern's class is going to be min of her marks in different midterms MJ. Okay. In one of her classes, Nancy has scored 40 on her first midterm and 50 on her second midterm. When the first midterm score is measured on the horizontal axis, okay, so this is midterm score on horizontal axis and second midterm on the vertical axis. Her indifference curve has a slope of 0 at that point. Okay, so the question here has not revealed that which course is he talking about. He's just saying that at 40 comma 50, so this is the point 40 and this is the point 50. At 40 comma 50, second midterm on the vertical axis, her indifference curve has a slope of 0 at point 40 comma 50. Okay, so first let's draw both these indifference curves. So max of let me say this course is course L. So max of L1 comma L2, and this course is, let's say, course N. So min of N1 comma N2. So the max function along the 45-degree line, the max function will look like this. And the min function, it will look like this. Okay, and this is the point 40 comma 50. So you have to draw both these curves. Okay, you have to draw both these curves, and then what he's saying is, let me say this 45-degree line. And then what he's saying is that indifference curve has a slope 0. So at this point, which IC has a slope 0? Is the green IC having a slope 0, or the red IC having a slope 0? Yes, Kashish, this question is to you. Which indifference curve passing through the black dot here? Kashish, are you with us?
Yes, sir.
So is the red curve having a slope 0 at this point or the green curve? Just look at it and tell me what is slope 0, Kashish? What is slope 0? Slope 0 means what? Kashish?
I don't know.
Huh?
I don't know.
Slope 0 is flat line. Horizontal line is slope 0. Slope क्या होता है? A mountain has a slope. You say nothing has a slope means it's flat. It's apart. So the red line has slope 0 or the green line has slope 0?
It's a red line.
Very good. Okay, so that's all. Slope is something which is English. It's not even math. Okay, 0 is math, but slope 0 is something which is flat. So the red line has slope 0. So that's why this is going to be following the Professor Goodhart's course. So answer is A. Okay, next out.
Sir, from 23, 3.23.
Okay, Tommy Twit's mother measures the departure of any bundle from her favorite bundle for Tommy by the sum of the absolute values of the differences. Okay, so her favorite bundle for Tommy is 2,7. That is 2 cookies and 7 glass of milk. Tommy's mother's indifference curve passing through the point also passes through. So first of all, you have to build the utility function. Okay, so the question tells you that she measures the departure of any bundle from a favorite bundle for Tommy by the sum of absolute values of the differences. Okay, so so her favorite bundle is 2,7. So the utility is mod of cookies minus 2 plus mod of milk minus 7 whole negative. So why am I assuming this utility function? So her utility is measured by this thing because any departure from 2,7 will reduce the utility first of all. So so that captures the idea that 2,7 is the ideal bundle because this is the point where u max equals to 0 is reached. The second thing is it captures the idea that the departure of any bundle is the sum of absolute values of differences. So these are the differences. This is the sum. So sum of absolute values of the differences. So this is a very commonly used utility function to measure how far away you are from the ideal bundle. So if you want to be as close to the ideal bundle as possible, you can go with this thing. Another way to capture the similar thing would be negative of c minus 2 whole square plus m minus 7 whole square, something we did right now. But the difference is now the departure is not sum of absolute values, it is sum of squares. So had the word been sum of squares of the differences, then this would have been the utility function. But that's not the case here. So we are going to rely on this particular utility function. Now I want to look at what happens to the ICs. Okay, so I want to draw the ICs and look at them. So first of all, I look at the point 2,7. Okay, and draw the horizontal and vertical lines along. So here okay, first of all, you can just substitute the values and check. Okay, once you have this utility function, the answer is very straightforward. You can substitute the values and check. So let me put 3,6. So utility at 3,6 is going to be negative of mod 3 minus 2 minus mod of 6 minus 7. What is this value going to be, Kashish? Hello? Yeah.
0.
Why 0? What is mod of 3 minus 2? Oh no, sorry, I wrote minus. Sorry, my bad. I should have written plus. Yeah, tell me the value. Sorry, the function is plus. What will be the value?
Sir, 2.
Yeah, negative 2 actually. Minus of 2.
Yes, sir.
So right now you have minus of 2. Then just substitute these different points and check which of them is giving minus 2. So that will solve your answer. Okay.
Yes, sir.
So your doubt is done. Now I want to delve into something other. What are going to be the ICs of this particular thing? So I can break it down into 4 zones. This is the zone when C is greater than 2 and M is greater than 7. So when C is greater than 2 and M is greater than 7, your utility function becomes negative of, when C is greater than 2, this mod opens as it is. So C minus 2 plus M minus 7. So that is negative of C minus 9. Okay. So negative of C minus 9 equals to something. So it is basically, sorry, C plus M minus 9. Negative of C plus M minus 9. So C plus M is the dominant feature here. C plus M equals to something. So it's going to be a 45-degree slope like this. Now let's look at this zone. In this zone, you have C less than 2, but M greater than, no wait. Where are cookies? These are cookies and this is milk. So I'm going in this territory. So milk is less than 7. So cookies still greater than 2, milk less than 7. So this utility function is going to be negative of C is greater than 2. So C minus 2 plus M is less than 7. So 7 minus M. So it's going to be negative of C minus M plus 5. The important thing is C minus M is the dominant feature here. So you have a line of the format C minus M equals to some value K. For some level of utility U0, you will have this sort of format. Okay, so this becomes X minus Y equals to something. So the slope becomes Y equals to X plus something. So slope becomes plus 1. So the slope is going to be this much. So in fact, the ICs are going to look like this. So they are going to look like a square kite. Okay, so in the case of any utility function of the format negative of mod x naught minus x plus y naught minus y, the ICs, they are going to look like this structure always. Okay, so this is going to be your point x naught comma y naught. And along this point, you can construct these vertical and horizontal lines. And then your ICs, they are going to look like this. Okay, you get the idea. I'm trying to be unnecessarily meticulous, but you get the idea. So the ICs are going to look like this. Okay, so they are going to be rotated squares. So that is going to be the shape of the interface squares. Regarding the question like this, you can just substitute the values and check which of these things is giving a similar utility as the one in the point mentioned in the 3,6. So just substitute these values in the utility function and check which of them is giving the same utility -2. Okay, next.
So 24 or 24.
You have to be louder.
So 24.
24. Okay. Professor Chaos, two tests in this course and determines the student's grade as follows. He calculates the smaller of the two following two numbers. Half of the score on the first test, which is a relatively easy test, and the actual score on the second test. He gives each student a numerical score equal to the result of this calculation and ranks his student. Okay, so he takes the half of the score in first test and the second test and does some sort of calculations on it. Smaller of the following two numbers. He does minima of these two numbers. Scholastica would like to be ranked as high as possible in Professor Chaos's ranking. If we represent her score on the first exam on the horizontal axis and the second on the vertical axis, then her ICs. So this is just min of x by 2 comma y. Why couldn't you do this, Kashish? You have done this. How do we find min of x by 2 comma y? Hello, Kashish. Please don't mute the mic when I'm talking to you.
Yes, sir.
Yeah, so tell me, how do I do this? What used to be the first step? What was the first step? Okay, you need to revise those videos. I'll share those videos again for min-max functions, or maybe take a makeup lecture because clearly you have a lot of doubts in that. So I'll take a lecture on that, and then maybe we can, because this is bread and butter. I mean, this is something we have dealt with. I cannot do this again and again, and it will just bore the other students. So let's take a doubt session on this for you and somebody else. I guess you, Akshi or Kritika, somebody had missed that class, so I'll take a doubt class on that. Well, this is very simple. Okay, so I'll be going in circles on the same thing. I don't want to do that. Okay, yeah. Next,
Sir, I have from chapter 5.
okay, let me open up chapter 5. Yeah, tell me, question
Sir,
number.
true, false, 8, 5.8.
Linus has a utility function x plus 2y. Price of x is 1, price of y is half. Then Linus must consume equal amounts of both goods in order to maximize utility. So if MRS equals to price ratio, this is that kind of question. So MRS for this case is half, and that is equals to price ratio. So what happens in this case is the budget constraint and indifference curve are coincidental. So you can be on any point here. All the points are going to be equally costly and equally fulfilling. That is, the utility is going to be the same. All right, so you can put him on any point. You can put him here, you can put him here, or you can put him on the midpoint. So it's not necessary that he must consume equal amounts of both goods. He can consume anywhere on this line. So that's why it's false.
Sir, 5.10.
Millie's utility function is min of x comma y. She maximizes her utility subject to a budget constraint. Somebody Millie's utility function is min of x comma y. She maximizes her utility subject to a budget constraint. The price of x is same as the price of y. If the price of x rises and the price of y and her income remain constant, then her consumption of y will certainly decrease. Okay, so in this case, she has a limited budget in which she's trying to do. So you have to find the Marshall demand for good x and y. So we have seen that x star comma y star in this case is I by px plus py. In fact, x star is equals to y star equals to I by px plus py. This is what we get in case of main function. If you go back to the notes where we derived
Yes, sir.
indirect utility function and everything, you'll find that this is the situation. Solving this is very easy. Okay, so you should have, because you have min function, you should have x equals to y, and then you just put this in budget constraint, px into x plus py into, instead of y, I'll write x equals to I, which implies x equals to I by px plus py, and that should be equal to y. So x should be equal to y equals to I by px plus py. Now, if the price of x rises and the price, so even if income and py remain constant, just focus on this bit now. Okay, forget what's happening to x. So even if x is rising, price of x is rising and price of y is constant, her consumption of y will reduce, which is very normal, right? Which is very normal. You see, when eggs become costly, or rather when there's a scare of bird flu, every time there's a scare of bird flu, bread demand reduces, the demand for bread reduces, because these are complements, right? You eat them together. So it's something similar which is happening, that x is becoming costlier, which is reducing the demand for y as well. Okay, so that's true. Okay, what next?
So 5.11.
We did this, right? We did lump sum principle of taxation.
No, sir. Sorry. It was
What?
5 point. No, I got that. We did that. Yeah, I remember.
Yeah.
Actually, it contains some of Kanishka's doubts also, and she's not able to take class due to some emergency. So I just mixed up both the numbers.
Sorry, I can't hear you. Can you repeat what you just said?
Hello.
Yeah.
Sir, question number 5.33.
5.33.
Yes.
Okay, mod's utility function is utility equals to x1 into x2. His income is $100. The price of good 2 is $10. Okay, so P2 is 10. Income is 100. Good one's priced as follows. The first 6 units cost $10 per unit. Any additional units cost 5 per unit. What consumption bundle does mod choose? Okay. So first we have to draw the budget constraint of this guy. So first we have to draw this guy's budget constraint. So let's say this is, so what is the maximum amount of good X that he can consume? The price of good 2 is, okay, price of good 2 is fixed, $10. So the maximum amount of good 2 that he can purchase is 10. Okay, the first 6 units cost 10 per dollar. So X till 6 units is going to cost you 10 per dollar. So if you consume 6 units of X, you can consume only 4 units of Y. So this is till this point, your budget constraint is going to look like this 45-degree line. Okay, so till this point, you will have P 10X plus 10Y equals to 100. So that's going to be the case. After this, any additional units cost 5 per unit. So after this point 4, 10, what happens is if you give up 1 unit of good Y, you don't get 1 unit of good X, you get 2 units of good X. So till now, what was happening is if you give up 1 unit of good Y, you gain 1 unit of good X. So this became the point. So this was 0, 10. This became the point 9, 1, and so on till the point 6, 4. But after this, giving up 1 unit of Y will give you 2 units of X. So the slope will look like this. This is what the indifference curve is going to be like. Okay. So we have been asked what consumption bundle does malt choose? So the important thing here is drawing the drawing the budget constraint, because the budget constraint is no longer a straight line. It is going to be kinked here. So now I want to find out which point will he consume. So yeah. So one way to do this is, obviously he cannot choose this point. One thing to understand is that this kink point K, it will not be chosen. The 6, 4 can never be chosen. Why can it not be chosen? Because at 6, 4, what's happening is either the indifference curve will pass like this. Okay, so this is case 1, which means that there's going to be higher indifference curve here, another tangency here. So this point is going to be a higher utility case. All right. So if IC through point K looks like case 1, then definitely this point cannot be the highest utility point. Right? Okay. Let's look at another case. So in case 2, let's say indifference curve looks like this through K. So in this case, there will be a higher utility point here. So under case 2 also, you cannot have this point as the highest utility. Okay. And you cannot have a tangency condition here. That is important. Either the IC will be, either case 1 or case 2 will happen. Either of these 2 cases will happen. One more thing which can happen is something like, no, that won't happen in this case. Okay, so this is, let's say, the K point. So you will never have a situation where the indifference curve does not pass through either this line or that line. This is the point K. Either this has to happen or this has to happen. So it has to be cutting either this line or that line, because the slopes are different on the 2 sides. Okay. So you cannot have K as the highest utility. This point is not the optima. So now the question arises, if this point is not the optima, then what is the optima? So one way to check is, so this is where it gets interesting. Now, how do we find the optima? So one way to check would be take this as the budget line for once. Assume that Px by Py is 1 and solve it, find the optima. The second case would be assume that Px by Py equals to half and find the optima. Okay, and compare the 2 optimas, which of them is higher. But obviously that is tedious. So let me give you a shortcut to find out in which of the segments will the optima lie. Okay, so the point is that either your optimum will lie like this, okay, or your optimum will lie like this. One of these is the optimas. I have to figure out which is the true optima. So the answer is hidden in the indifference curve if passes through the point K. So what is the slope of the indifference curve through K? That is MRS. What is the MRS at the point 6, 4? What is the MRS at point 6, 4? Who asked this question? Was it Kritika? What is the MRS, Kritika, at 6, 4? This is my utility function. Kritika, can you hear me? Hello, can anyone hear me? Yuvakshi, can you hear me?
Yes, sir.
Okay, I don't know what happened to Kritika. Why don't you tell me the MRS at 6, 4?
Mm,
Yuvakshi, come on, what is the MRS
4
formula?
by 6.
Very good. Y by X, 4 by 6. So that is the MRS, okay? 4 by 6 is basically 2 by 3, right? So 2 by 3 is the MRS. What is the slope of this segment, the blue segment? It's 1.
1.
Yeah. And the slope of this segment is half. Now 2 by 3 is between half and 1. Okay. So the tangent at point K to the indifference curve passing through the point K is going to look like this. It's going to be between these two lines, right? So the indifference curve will actually be something of this form. Okay, because this is the only way you can draw an indifference curve. So the indifference curve's slope is such at K. At K, the slope is such that it is going to intersect this point here. Why do I say that? Okay, why do I say that? The reason I say that is, okay, this is 2 by 3, right? So if I construct these lines ahead like this and like this, okay, so if I were to construct these lines completely, then the slope at this point will look something like, so the slope at point K for the indifference curve will look like this, 2 by 3. It is going to be between these slopes, right? So it should be passing between the two curves. And then when I draw the indifference curve from this point, it must be something of this format. Okay. No, wait, it is 2 by 3 is between. I can actually get something which goes through here. Okay, wait. 2 by 3 is between these 2 points, right? Oh, the shortcut does not apply in this case, actually. Let me draw a zoomed in figure here to explain you the problem. So the problem is one line is sloped at 45 degrees and the other line is sloped at whatever slope half. So my indifference curve is passing through them like this. sorry, not my indifference curve, but the slope of the indifference curve is passing through them like this. What it means is that my indifference curve could take this particular format. Okay, it can take this particular format. So the problem with this particular format is that you could have an optima here and you could have an optima here. So you actually have to check both the segments separately. Okay, so you can have an indifference curve which crosses through both the arms in this case. Had it been greater than 1 or less than 1/3, then the case would have been something else. Okay, so that's the case where the shortcut applies. So we'll see one such question in the future in past year where this thing will be applicable, where the shortcut will be applicable. So here the problem is that MRS 2/3 is between 1 and 1/2. So the shortcut is not applicable. So the only way to do this is assume the different slopes and find the optimas for different things. Okay. So at phi comma phi, sorry, not at phi comma phi, at px by py equals to 1, the optima is phi by phi comma phi. Okay, and at px by py equal to 1/2, the optima would be the optima is going to be twice or as much. So price of x is half that of price of y. So x will be consumed twice. So price, so x star, so you will spend, okay, so you are going to be on this territory. Okay, so what is going to be the optima here? So assuming 1 and 2, the optima is going to be that you're going to divide this in 100/3 for x. Px by py is not half, it is 2. So 100/3 for x and 200/3 for y. So x is going to be consumed with x is half. So mistakes. I'm trying to do this fast. I'm sure with sufficient time you can apply all Lagrangian and do it with some effort. I want to proceed faster to check. So that's why I'm skipping some steps. So expenditure on good x is going to be 200/3. Expenditure on good y is going to be 100/3. Right. No, it's going to be 50 each. What am I doing? Yeah, expenditure on x is 50, expenditure on y is 50. So x star is going to be, since price of good x here is 5 rupees at this level, so x star is going to be equal to 10 and y star is going to be equal to 5. All right, so if this were the case, then you would be consuming the bundle 10,5. Which is going to be somewhere here, and this bundle is going to be 5,5 10,5 and applicable.
Hello.
Yeah, I have to do it from with the step. Sorry. Yeah, Himandi, you were saying?
Can we do budget constraint problem for both the lines and then check the maximum utility of each option?
Yeah, that's what I'm doing. I was trying to introduce this. This See, that is definitely an option that you have two different this blue line and green line. So you assume once the blue line, other time you assume the green line, and then you find out what's going to be the case. But for this case, the mistake I did is I assumed the budget to be constant. So let me tell you what's happening. So here, if I assume Px by Py to be equal to half, I cannot take my income to be 15 because uh, my actual budget line looks like this. The problem with X is that it is behaving as one price for till some level, and after that it is behaving as some other price. So I want to piecewise solve this. First, find the optima for red case, which I did, and found it out as 5,5. Now I want to find the optima for the black case. The problem with black case is that I cannot take my income to be 100 and Px to be equal to 5 and Py to be equal to 10. Because if I do that, what happens is that the line I will get is this line, which is not the line I want to check. I want to check on this line. So what I want to do is find an income which gives me this entire line. Right? So what is going to be the income which generates this particular line? So for that, I know this point. This point is 6,4. I know Px by Py is equals to half. So I can use this, or rather Px equals to 10. Px equals to 10, no, 5. Py equals to 10. So just substitute this in this case to find the hypothetical income on which a customer would satisfy this particular budget line for this level of prices. So I prime equals to 5 into 6 plus 10 into 4. So that is 30 plus 40. So that is equal to 70. So with income 70, now you find out what is going to be the optima for Px by Py equals to half. Okay, so for income equals to 70, Px equals to 5 and Py equals to 10. When we find the optima, we are going to find the optima on this line. Okay, so when we do that for utility equals to xy, we will see that x star is going to be 35 by 5 and y star is going to be 35 by 10. So that is equal to 7, 3.5. So the ideal point here is going to be 7, 3.5, which is this point. So this point is 5.5. That is going to be the max utility on the left side of the budget line, and 7, 3.5. Let me remove these numbers. Is the max utility on the right arm of the budget line. And then what we do is we just compare these two bundles. So the utility here is 5 into 5, so that is 25, and the utility here is 7 into 3.5, which is 21 plus 3.5, so that is 24.5. So obviously 5, 5 is giving a higher utility, so this is the true optima. Okay. So it's a slightly lengthier problem, but this is the only way to do it. I have introduced some shortcut which I was not able to apply here. I will introduce it in a later problem in the past year where we can basically reject one of the cases that this will not happen. Yeah, what else?
Sir, 5.29.
Angela consumes only two goods, X and Y. Her income doubles and the price of the two goods remain unchanged. Income doubles and price of the two goods remain unchanged. Assuming that she is a utility maximizer, and likes both goods, which of the following statements is necessarily true? She will consume more of both goods. The ratio of consumption of X to Y remains constant. Her utility doubles. If her preferences are convex, she must consume more X. Okay. So none of these necessarily true. So suppose you have utility equals to ln X plus Y. So I know that in this case, after if you're sufficiently rich, the amount of X will be fixed at X star. Okay, so X is fixed at X star. You do not consume more than X star if you are sufficiently rich, if your income is above some threshold. So even if you become richer and richer, even if your income doubles, you are not going to consume more of good X. So that rejects A, that also rejects B, okay, and that also rejects C at some level, because if your income doubles, you cannot be sure that your utility would double. For example, let's say, so to reject option C, you can take a different situation. You can take utility equals to XY. Okay, so in this case, if you were initially consuming some bundle, let's say X bar comma Y bar, when your income doubles, you will consume 2X bar comma 2Y bar. So your utility may not double, it will go 4 times when you go from here to here. If your utility here was U0, utility here would be 4 times U0. So this becomes false. Fourth is, if her preferences are convex, she must consume more X. Again, untrue according to this example. These are convex preferences. Okay, these are convex preferences. Yet her amount of good X does not increase. So that is rejected. So all the 4 options are rejected. The only true option is the E option. None of the above. All right. Next.
Sir, 5.38.
Justin consumes X and Y and has utility function X square plus Y. The price per unit of X is Px and the price per unit of Y is Py. He has enough money so that he can afford at least 1 unit of either good. When he chooses his best affordable bundle, it must necessarily be that. Okay, so these are also your what do you call them? Quasi-linear preferences. Okay, but these are not necessarily convex. Why are they not necessarily convex? Because imagine any utility level U0. Okay, so your utility function is X square plus Y. So suppose you are talking about utility level of 10. So this implies X square equals to Y minus 10. Oh, sorry. Y equals to 10 minus X square. Okay. Now, minus X square curve looks like this. Right? Basically, you can derive the slope of this curve using X square curve. Okay, so X square curve looks like this. So minus X square curve looks like this. And 10 minus X square curve will look like this. So I'm only interested in the negative X square part. So it will look like this. Sorry, this is convex actually. Yeah, this is convex. This is Y. This is x, y equals to 10 minus x squared. This is convex. Oh, no, this is not convex. Convex look like this. So this is concave preferences. Sorry for the confusion. This is not convex. Okay, now what happens for any utility level that we want to reach? So this is some preferences that you have, okay, which look like this. Now, if you want to, okay, he has enough money so that he can afford at least 1 unit of each of either good. So he has a budget line which passes through the point 1, 1. So let's say this is the point 1, 1. So he has a budget line which passes through this point. So when he chooses his best affordable bundle, then it must necessarily be. Now, he will not pick this point, because if you draw the budget line at this point, it will look something like this. Okay, not necessarily something like this. It can go like this also, or it can be like this also. The point is, no matter how you draw it, you can find a higher indifference curve on this budget line. So he's not going to pick the point of tangency, that's for sure. What he's going to pick is, he is going to pick either the x coordinate or the y coordinate, sorry, the x intercept or the y intercept. This is what he will do always, no matter how you draw it. Okay, so even if you draw it looking like this, a tangent, even in that case, either this is going to be the indifference curve he purchases, or this is going to be the indifference curve that he picks. Okay, so depending on what the slope is, he always picks either the x-intercept or the y-intercept. So how do I find that? So how do I find what intercept he's going to pick? So the first thing to identify is that he always picks either the x-intercept or the y-intercept. Okay, so what if he picks the x-intercept? If he picks the x-intercept, the amount of good x that he consumes is going to be I by px, which means that the amount of utility that he gets is going to be I by px whole square. Okay. And if he picks the y-intercept, he will pick y star equals to I by py. So the value of utility that he'll get is I by py. Now, which value is larger will decide what he does. What else is given here? The price per unit of x is px, price of y is py. He has enough money so that he can afford at least 1 unit of each good. So income is greater than px and income is greater than py. This much is given to me. So I by px is greater than 1 from here, what I get. This means that I by px okay, he will consume good x only if I by px whole square is greater than I by py, which implies that I by px is greater than px by py, which means that I is greater than px square by py. Okay, so from here, what I can derive is Okay, this does not give me any other additional information. So the idea is that he'll consume x-intercept if I is greater than px square by py. Okay, so if I greater than px square by py, he consumes only x, and if I is less than px square by py, he consumes only y. So that is the final answer. So it is option C. He consumes y if px square by py exceeds his income. Okay. So this is going to be the nature of concave curves. So when you have concave curves, it's going to pick either the x or the y-intercept. All right. Next.
Sir, I had this doubt in these quasi-linear preferences. Is that every time true that only X or only Y will be consumed?
No, that was not true for convex quasi-linear preferences. We arrived at x star equals to something. If you go back to convex quasi-linear preferences, that's not true. In fact, that's the nature of concave preferences. It's nothing to do with quasi-linear. The thing is with concave preferences, that in concave preferences, it sometimes happens. Even for max case, it is true, right? Even for the case of max functions, we saw that you either consume only good x or only good y or good x. So that is a feature of concave preferences,
Okay,
not
sir.
not quasi-linear.
Yeah, sir, from essay type questions, 5.2 and 5.6.
Casper consumes cocoa and cheese. Cocoa is sold in an unusual way. There is only one supplier, and the more cocoa you buy from him, the higher the price you have to pay for it. In fact, y units of cocoa will cost Casper y square dollars. Cheese is sold in a usual way. Price is $2 per unit. Casper's income is $20, and his utility function is x plus 2y. Okay, so the budget constraint is going to be 2 times x plus y square is equals to 20. So 2x plus y square equals to 20. So you can plot it, right? So 2x plus y square equals to 20. How do you plot it? Let's look at some simple way to plot it without using derivatives and everything. So 2x plus y square equals to 20. This implies that x equals to 10 minus y square by 2. Okay. So x equals to y square looks like this. This is a graph for x equals to y square. So this will be the graph of x equals to minus y square. So x equals to 10 minus y square by 2 will look something like this. So we are just interested in the positive x terrain. So it's going to be like this. So it's going to be concave. Okay. So you can draw these curves without using higher algebra. I don't want you to be spending time accurately drawing the curves. That's not the point. So this is the budget set approximately. This is y and this is x. Right, this is right. Y square x equals to y square. X equals to minus y square. Yeah. So this is the budget constraint. Anything inside it is the budget set. So a rough idea. Sketch some of the indifference curve and label the point that he chooses. So the indifference curve is x plus 2y. So just draw some straight lines with y. So budget so the utility function is x plus 2y. So what is going to be the slope? Yes, Yuakshi, what is going to be the slope?
1/2.
1 by 2. Very good. So you just draw some slopes 1 by 2 ICs and show this tangency point as the picker point. Calculate the amount of cheese and amount of cocoa that Casper demands at these prices and this income. So just form the Lagrangian. So Lagrangian equals to x plus 2y minus lambda times of budget constraint is 10 minus x minus y square by 2. Okay, so form this Lagrangian and solve it. The reason Lagrangian works right now is that I'm again going to look at the tangency point. The tangency point is going to be the ideal point. So it did not work in the usual perfect substitute case, because when budget constraint is linear and the ICs are also linear, the tangency point might not exist. Okay, so if these are the ICs and this black line is my budget line, then the tangency does not even exist. So I'm going to find one of these things. So tangency does not exist. But now one of the curves is again non-linear. So you'll again be looking at a tangency. So when tangency happens, Lagrangian, when tangency solution is the ideal solution you're looking for, then Lagrangian is going to give you the correct answer. So the whole point is that you should be able to draw the graph and know beforehand if you're looking for the tangency solution or not. If tangency solution is something that you're looking for, then Lagrangian is good. Okay. So you solve this Lagrangian and you will get your answer. What was the next one?
So 5.6.
Less has utility function x plus 1 into y plus 4. The price of y is 1. Okay, price y is 1. Les spends all of his income to buy 6 units of y and no x. From these facts, we can tell that the price of x must be at least how much? Please explain your answer and draw a diagram to illustrate it. Okay, x plus 1 into y plus 4. Okay, so let x plus 1 equals to capital X, implies x equals to capital X minus 1. And y plus 4 equals to capital Y, which implies that y is equals to capital Y minus 4. Okay. So this is the point minus 1. When is x, y 0? So x is 0 when capital X is 0, when small x is minus 1. Okay, x equals to 0 implies small x equals to minus 1, y equals to 0 implies small y equals to minus 4. So at minus 1 comma minus 4, if you look at this point, okay, if you make these substitutions, the utility function becomes capital XY. So if this were the origin, my ICs would look like this. Normal Cobb-Douglas case. Okay, but the actual origin is this. So I will only be focusing on the part in the first quadrant. I'll not be looking at the part 2 in the other regions, but this is what helps me find the shape of the indifference curve. Okay. Les spends all of his income to buy 6 units of Y and no X. So he's consuming at a point like this, 6, 0, 6. So his budget line should be something like this, or even steeper. Okay, so what is 0,6? First of all, I want to find the MRS of this thing, 0,6. What is going to be the slope of 0,6? So you can just use this case to find the slope. Okay, so MRS is going to be equal to y plus 4 upon x plus 1. So at 6,0, this becomes 10 by 1. So that is equals to 10. So px upon py must be greater than 10. So when px upon py is greater than 10, you do not want to consume anything else. You want to stick to this point 0,6. Okay, so price of x must be, okay, has it given me the price of y? Price of y is y, 1. So price of y is 1, so px must be at least 10. Okay. All right, all the others have left the discussion. So let us stop here for today. And let's take another discussion session next week. Have you done chapter 6, Yuvakshi?
Yes, yes, sir. And I have actually, sir, today's doubts also consist some of Kanishka's because she has to go somewhere urgently in the morning. She gave me her doubts also. And chapter 6, we both had extensive doubts, I guess. So it's fine
Okay,
if you want
sure.
to take in the next
Yeah,
class.
yeah.
She will be there also.
Yeah, cool. We'll take it sometime in the weekdays. Okay.
Okay, sir.
All
Thank
right.
you.
Right, sure.